Good afternoon, dear students of ITE 6201E, Social Issues and Professional Practice. I am your OLC, Ms. Karen Lara, and welcome to our virtual class today. We will be discussing the following: what is artificial intelligence or AI, the history of artificial intelligence, the four types of artificial intelligence, the importance of artificial intelligence, the applications of artificial intelligence, how artificial intelligence works, the risks of artificial intelligence, and working with artificial intelligence. What is artificial intelligence? The ability of a digital computer or computer controlled robot to perform tasks commonly associated with intelligent beings. A wide ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. Artificial intelligence today is properly known as narrow AI or weak AI, in that it is designed to perform a narrow task like only facial recognition or only internet searches or only driving a car. However, the long-term goal of many researchers is to create general AI or AGI or a strong AI. While narrow AI may outperform humans at whatever its specific task is, like playing chess or solving equations, AGI would outperform humans at nearly every cognitive task. Artificial intelligence history. The term artificial intelligence was coined in 1956, but AI has become more popular today thanks to increased data volumes, advanced algorithms, and improvements in computing power and storage. Early AI research in the 1950s explored topics like problem solving and symbolic methods. In the 1960s, the US Department of Defense took interest in this type of work and began training computers to mimic basic human reasoning. For example, the Defense Advanced Research Projects Agency or DARPA completed street mapping projects in the 1970s, and DARPA produced intelligent personal assistants in 2003, long before Siri, Alexa, or Cortana were household names. This early work paved the way for the automation and formal reasoning that we see in computers today, including decision support systems and smart search systems that can be designed to complement and augment human abilities. While Hollywood movies and science fiction novels depict AI as human like robots that take over the world, the current evolution of AI technologies isn't that scary or quite that smart. Instead, AI has evolved to provide many specific benefits in every industry. Now let's discuss the timeline of artificial intelligence. 1943, Warren McCullough and Walter Pitts published a logical calculus of ideas immanent in nervous activity. The paper proposed the first mathematical model for building a neural network. 1949, in his book The Organization of Behavior, a neuropsychological theory, Donald Hebb proposes the theory that neural pathways are created from experiences and that connections between neurons become stronger the more frequently they're used. Hebbian learning continues to be an important model in AI. 1950, Alan Turing publishes Computing Machinery and Intelligence, proposing what is now known as the Turing test, a method for determining if a machine is intelligent. Harvard undergraduates Marvin Minsky and Dean Edmonds build SNARC, the first neural network computer. Claude Shannon publishes the paper Programming a Computer for Playing Chess. Isaac Asimov publishes The Three Laws of Robotics. 1952, Arthur Samuel develops a self-learning program to play checkers. 1954, the Georgetown IBM machine translation experiment automatically translates 60 carefully selected Russian sentences into English. 1956, the phrase artificial intelligence is coined at the Dartmouth Summer Research Project on Artificial Intelligence, led by John McCarthy. The conference, which defined the scope and goals of AI, is widely considered to be the birth of artificial intelligence as we know it today. Allen Newell and Herbert Simon demonstrate logic theorist, or LT, which is the first reasoning program. 1958, John McCarthy develops the AI programming language Lisp and publishes the paper Programs with Common Sense. The paper proposed the hypothetical advice taker, a complete AI system with the ability to learn from experience as effectively as humans do. 1959, Allen Newell, Herbert Simon, and J.C. Shaw developed the General Problem Solver, or GPS, a program designed to imitate human problem solving. Herbert Gelenter develops the Geometry Theorem Prover program. 1959, Arthur Samuel coins the term machine learning while at IBM. John McCarthy and Marvin Minsky founded the MIT Artificial Intelligence Project. 1963, John McCarthy starts the AI Lab at Stanford. 1966, the Automatic Language Processing Advisory Committee, or ALPAC, report by the US government details the lack of progress in machine translations research, a major Cold War initiative with the promise of automatic and instantaneous translation of Russian. The ALPAC report leads to the cancellation of all government-funded MT projects. 1972, the logic programming language Prolog is created. 1973, the Lighthill report, detailing the disappointments in AI research, is released by the British government and leads to severe cuts in funding for artificial intelligence projects. 1980, Digital Equipment Corporations develops R1, also known as XCON, the first successful commercial expert system designed to configure orders for new computer systems. R1 kicks off an investment boom in expert systems that will last for much of the decade, effectively ending the first AI winter. 1982, Japan's Ministry of International Trade and Industry launches the ambitious fifth generation computer systems project. The goal of FGCS is to develop supercomputer-like performance and a platform for AI development. 1987 to 1993, as computing technology improved, cheaper alternatives emerged and the Lisp machine market collapsed in 1987, ushering in the second AI winter. During this period, expert systems proved too expensive to maintain and update, eventually falling out of favor. 1991, US forces deployed DART, an automated logistics planning and scheduling tool, during the Gulf War. 1992, Japan terminates the FGCS project, citing failure in meeting the ambitious goals outlined a decade earlier. 1997, IBM's Deep Blue beats world chess champion Garry Kasparov. 2005, Stanley, a self-driving car, wins the DARPA Grand Challenge. The US military begins investing in autonomous robots like Boston Dynamics Big Dog and iRobot's PackBot. 2008, Google makes breakthroughs in speech recognition and introduces the feature in its iPhone app. 2011, IBM's Watson trounces the competition on Jeopardy! Apple releases Siri, an AI-powered virtual assistant, through its iOS operating system. 2014, Google makes the first self-driving car to pass a state driving test. Amazon's Alexa, a virtual home, is released. 2016, Google DeepMind's AlphaGo defeats world champion Go player Lee Sedol. The complexity of the ancient Chinese game was seen as a major hurdle to clear in AI. The first robot citizen, a humanoid robot named Sophia, is created by Hanson Robotics and is capable of facial recognition, verbal communication, and facial expression. 2018, Google releases natural language processing engine BERT, reducing barriers in translation and understanding by machine learning applications. Waymo launches its Waymo One service, allowing users throughout the Phoenix metropolitan area to request a pickup from one of the company's self-driving vehicles. 2020, Baidu releases its linear fold AI algorithm to scientific and medical teams working to develop a vaccine during the early stages of the SARS-CoV-2 pandemic. The algorithm can predict the RNA sequence of the virus in just 27 seconds, 120 times faster than other methods. Now let's proceed with discussing the four types of artificial intelligence. The first one is the reactive machines. A reactive machine follows the most basic of AI principles and, as its name implies, is capable of only using its intelligence to perceive and react to the world in front of it. A reactive machine cannot store a memory and, as a result, cannot rely on past experiences to inform decision making in real time. A famous example of a reactive machine is Deep Blue, which was designed by IBM in the 1990s as a chess playing supercomputer and defeated international grandmaster Garry Kasparov in a game. Deep Blue was only capable of identifying the pieces on a chessboard and knowing how each moves based on the rules of chess, acknowledging each piece's present position and determining what the most logical move would be at that moment. Another example of a game playing reactive machine is Google's AlphaGo. AlphaGo is also incapable of evaluating future moves, but relies on its own neural network to evaluate developments of the present game, giving it an edge over Deep Blue in a more complex game. AlphaGo also bested world-class competitors of the game, defeating champion Go player Lee Sedol in 2016. Though limited in scope and not easily altered, reactive machine artificial intelligence can attain a level of complexity and offers reliability when created to fulfill repeatable tasks. The second one is the limited memory. Limited memory artificial intelligence has the ability to store previous data and predictions when gathering information and weighing potential decisions, essentially looking into the past for clues on what may come next. Limited memory artificial intelligence is more complex and presents greater possibilities than reactive machines. There are three major machine learning models that utilize limited memory artificial intelligence. One is the reinforcement learning, which learns to make better predictions through repeated trial and error. The second one is the long short term memory, or LSTM, which utilizes past data to help predict the next item in a sequence. LTSMs view more recent information as most important when making predictions and discounts data from further in the past, though still utilizing it to form conclusions. The third one is the evolutionary generative adversarial networks, or EGAN, which evolves over time, growing to explore slightly modified paths based off of previous experiences with every new decision. This model is constantly in pursuit of a better path and utilizes simulations and statistics, or chance to predict outcomes throughout its evolutionary mutation cycle. The third one is the theory of mind. The theory of mind is just that theoretical. We have not yet achieved the technological and scientific capabilities necessary to reach this next level of artificial intelligence. The concept is based on the psychological premise of understanding that other living things have thoughts and emotions that affect the behavior of oneself. In terms of AI machines, this would mean that AI could comprehend how humans, animals, and other machines feel and make decisions through self reflection and determination, and then will utilize that information to make decisions of their own. Essentially, machines would have to be able to grasp and process the concept of mind, the fluctuations of emotions in decision making, and a litany of other psychological concepts in real time, creating a two-way relationship between people and artificial intelligence. The fourth one is the self-awareness. One's theory of mind can be established in artificial intelligence sometime well into the future. The final step will be for AI to become self-aware. This kind of artificial intelligence possesses human level consciousness and understands its own existence in the world, as well as the presence and emotional state of others. It would be able to understand what others may need based on not just what they communicate to them, but how they communicate it. Self awareness in artificial intelligence relies both on human researchers understanding the premise of consciousness and then learning how to replicate that so it can be built into machines. Next, let's discuss the importance of artificial intelligence. AI automates repetitive learning and discovery through data. Instead of automating manual tasks, AI performs frequent, high volume, computerized tasks, and it does so reliably and without fatigue. Of course, humans are still essential to set up the system and ask the right questions. AI adds intelligence to existing products. Many products you already use will be improved with AI capabilities, much like Siri was added as a feature to a new generation of Apple products. Automation, conversational platforms, bots, and smart machines can be combined with large amounts of data to improve many technologies. Upgrades at home and in the workplace range from security intelligence and smart comms to investment analysis. AI adapts through progressive learning algorithms to let the data do the programming. AI finds structure and regularities in data so that algorithms can acquire skills, just as an algorithm can teach itself to play chess. It can teach itself what product to recommend next online, and the models adapt when given new data. AI analyzes more and deeper data using neural networks that have many hidden layers. Building a fraud detection system with five hidden layers used to be impossible. All that has changed with incredible computer power and big data. You need lots of data to train deep learning models because they learn directly from the data. AI achieves incredible accuracy through deep neural networks. For example, your interactions with Alexa and Google are all based on deep learning, and these products keep getting more accurate the more you use them. In the medical field, AI techniques from deep learning and object recognition can now be used to pinpoint cancer on medical images with improved accuracy. AI gets the most out of data. When algorithms are self-learning, the data itself is an asset. The answers are in the data. You just have to apply AI to find them. Since the role of the data is now more important than ever, it can create a competitive advantage. If you have the best data in a competitive industry, even if everyone is applying similar techniques, the best data will win. How AI is being used today. Every industry has a high demand for AI capabilities, including systems that can be used for automation, learning, legal assistance, risk notification, and research. Specific uses of AI in industry include healthcare. AI applications can provide personalized machine and X-ray readings. Personal healthcare assistants can act as life coaches, reminding you to take your pills, exercise, or eat healthier. Retail. AI provides virtual shopping capabilities that offer personalized recommendations and discuss purchase options with the consumer. Stock management and site layout technologies will also be improved with AI. Manufacturing. AI can analyze factory IoT data as it streams from connected equipment to forecast expected load and demand using recurrent networks, a specific type of deep learning network used with sequence data. Life sciences. From ensuring drug safety to getting new therapies to market faster, AI technologies can unleash the full potential of data to solve some of our greatest health challenges. Banking. Artificial intelligence enhances the speed, precision, and effectiveness of human efforts. In financial institutions, AI techniques can be used to identify which transactions are likely to be fraudulent, adopt fast and accurate credit scoring, as well as automate manually intense data management tasks. Public sector. Artificial intelligence can make smart cities smarter. It can support national defense with mission readiness and predictive maintenance. Across the board, AI can improve program efficiency and effectiveness. How artificial intelligence works. AI works by combining large amounts of data with fast, iterative processing and intelligent algorithms, allowing the software to learn automatically from patterns or features in the data. AI is a broad field of study that includes many theories, methods, and technologies, as well as the major subfields. Machine learning automates analytical model building. It uses methods from neural networks, statistics, operations research, and physics to find hidden insights in data without explicitly being programmed for where to look or what to conclude. A neural network is a type of machine learning that is made up of interconnected units like neurons that processes information by responding to external inputs, relaying information between each unit. The process requires multiple passes at the data to find connections and derive meaning from undefined data. Deep learning uses huge neural networks with many layers of processing units, taking advantage of advances in computing power and improved training techniques to learn complex patterns in large amounts of data. Common applications include image and speech recognition. Computer vision relies on pattern recognition and deep learning to recognize what's in a picture or video. When machines can process, analyze, and understand images, they can capture images or videos in real time and interpret their surroundings. Natural language processing, or NLP, is the ability of computers to analyze, understand, and generate human language, including speech. The next stage of NLP is natural language interaction, which allows humans to communicate with computers using normal, everyday language to perform tasks. Additionally, several technologies enable and support AI, such as graphical processing units are key to AI because they provide the heavy compute power that's required for iterative processing. Training neural networks require big data plus compute power. The Internet of Things generates massive amounts of data from connected devices, most of it unanalyzed. Automating models with AI will allow us to use more of it. Advanced algorithms are being developed and combined in new ways to analyze more data faster and at multiple levels. This intelligent processing is key to identifying and predicting rare events, understanding complex systems, and optimizing unique scenarios. APIs, or application programming interfaces, are portable packages of code that make it possible to add AI functionality to existing products and software packages. They can add image recognition capabilities to home security systems and Q&A capabilities that describe data, create captions and headlines, or call out interesting patterns and insights in data. How can AI be dangerous? So most researchers agree that a super intelligent AI is unlikely to exhibit human emotions like love or hate, and that there is no reason to expect AI to become intentionally benevolent or malevolent. Instead, when considering how AI might become a risk, experts think two scenarios most likely. The first one is that AI is programmed to do something devastating. Autonomous weapons are artificial intelligence systems that are programmed to kill. In the hands of the wrong person, these weapons could easily cause mass casualties. Moreover, an AI arms race could inadvertently lead to an AI war that also results in mass casualties. To avoid being thwarted by the enemy, these weapons would be designed to be extremely difficult to simply turn off, so humans could plausibly lose control of such a situation. This risk is one that's present even with narrow AI, but grows as levels of AI intelligence and autonomy increase. The second one is that the AI is programmed to do something beneficial, but it develops a destructive method for achieving its goal. This can happen whenever we fail to fully align the AI's goals with ours, which is strikingly difficult. If you ask an obedient intelligent car to take you to the airport as fast as possible, it might get you there chased by helicopters and covered in vomit, doing not what you wanted, but literally what you asked for. If a super intelligent system it is tasked with an ambitious geoengineering project, it might wreak havoc with our ecosystem as a side effect and view human attempts to stop it as a threat to be met. Working together with AI. Artificial intelligence is not here to replace us. It augments our abilities and makes us better at what we do. Because AI algorithms learn differently than humans, they look at things differently. They can see relationships and patterns that escape us. This human AI partnership offers many opportunities, and it includes bring analytics to industries and domains where it's currently underutilized, improve the performance of existing analytic technologies like computer vision and time series analysis, break down economic barriers, including language and translation barriers, augment existing abilities and make us better at what we do, give us better vision, better understanding, better memory, and much more. The principal limitation of AI is that it learns from the data. There is no other way in which knowledge can be incorporated. That means any inaccuracies in the data will be reflected in the results, and any additional layers of prediction or analysis must be added separately. Today's AI systems are trained to do a clearly defined task. The system that plays poker cannot play solitaire or chess. The system that detects fraud cannot drive a car or give you a legal advice. To summarize, the world is on the cusp of revolutionizing many sectors through artificial intelligence and data analytics. There already are significant deployments in finance, national security, healthcare, criminal justice, transportation, and smart cities that have altered decision making, business models, risk mitigation, and system performance. These developments are generating substantial economic and social benefits. Yet, the way AI systems unfold has major implications for society. It matters how policy issues are addressed, ethical conflicts are reconciled, legal realities are resolved, and how much transparency is required in AI and data analytic solutions. Human choices about software development affect the way in which decisions are made and the way they are integrated into organizational routines. Exactly how these processes are executed need to be better understood because they will have substantial impact on the general public soon and for the foreseeable future. AI may well be a revolution in human affairs and become the single most influential human innovation in history. If you have any questions, please send a message through the LMS chat box, or you can also email me at kvdalara@amais.edu.ph. Thank you for listening and thank you for attending our virtual class today.